Hello and welcome back to another video. In this problem, we're asked to use a graph of f of x is equal to 1 minus 2 over x squared to estimate the value of the limit as x approaches infinity of the function to 2 decimal places. So basically what we have here is we need to plug this into a computer and get an approximation of the limit from that. So I have it pulled up here in Desmos. What we can see here is that we have just a pretty standard function. We're saying as x approaches infinity, what value does the function approach to 2 decimal places? And the way to ensure that you're getting it to 2 decimal places for a problem like this is to zoom probably unnecessarily far out and just scroll pretty far over and get the value of the function. Now, as we can see, the function is a limit. It's not a straight line. We can see it's going from 0.99999, right? And then at some point it just hits 1. So that means is that as we're getting closer and closer to larger and larger values of x, the value of the function is approaching 1. And the reason you zoom out so far is because, for example, with a problem like this, if we were to zoom out to, let's say, 1,000 is a pretty large number, we can see that that comes out to 0.996, right? And these values are all different, and you could say, okay, these are values close to 1. It probably is approaching 1, but you wouldn't know for sure, right? And we're doing it to 2 decimal places here, so it doesn't really matter, but just for safety's sake, we would say, okay, let's zoom out really, really far because we can on a modern calculator, and just say, okay, it's equal to 1. So therefore, we can say that the limit as x approaches infinity of f of x is equal to 1. We're also asked to use a table of values to estimate the limit. And if we take this, we basically say, okay, we have x and f of x. What are these values equal to? For this, we can just use powers of 10. Right, we have 10, 100, 1,000, 10,000, and these are the values of x that we get: 0.64, 0.96, 04, 0.996, 004, and 0.999, 0.0004. We can notice a couple things here. 1, we're also approaching 1, and 2, without finding further and further values of the function, we can notice a pattern here, right? And this sometimes happens with limits, right? If you were to ask me before solving this problem, what is the pattern as you approach, or as you increase by powers of 10 in the value of this function, I would have no idea. But if we look here, we have the numbers 6 and 4, and then it goes 9604, 996004. 99960004. We can notice every single time 999960004, we're adding another 9. And therefore we could say, if we're going off to infinity, we get 0.99999 off to infinity. We never actually reach 6. We'd have infinitely many 9s, and therefore we can say it's equal to 1. That's just another way to think about it. Of course, you could just keep plugging in values, but either way, you get that the limit as x approaches infinity of this function is equal to 1.